the next chapter, second chapter, vectors. We are taking a body here, a force is applied on the body. Now the body moves in this direction with some acceleration. When the force is doubled, acceleration becomes double. So according to magnitude of the force, acceleration is changing. Now the force applied in this direction, the acceleration will be in this direction. And according to direction of force, direction of acceleration also changes. So force is a physical quantity which has both magnitude and direction. Like that, according to magnitude and direction, the physical quantities are divided into three types, which are vector physical quantities called as vectors, scalar physical quantities which are scalars, tensor physical quantities which are called as tensors. Vectors, scalars, tensors. Let us see first one, vectors. Vectors means the physical quantities which have both magnitude and direction called as vectors. Both magnitude and direction, but some physical quantities they have both magnitude and direction, but they are not the vectors. That means vectors not only magnitude and direction, they should have some characters. So those characters of vectors are, first one, vectors follows the laws of vector addition. Laws of vector addition they follows, commutative law, associative law, distributive law, triangular law, parallelogram law, they follows. And the second one, vectors can be resolved into components, x component, y component. Like I am taking a force, this force which is an angle theta resolves into two rectangular components, fx, f cos theta, and fy, f sin theta. Like that, it resolves into rectangular components, So second character is vectors can be resolved into components. And the third character is, you see here I am taking a force of 100 Newton at the angle of 60 degrees. In this direction it is 100 cos 60, 1 by 2, 100 into 1 by 2, which is 50 Newton. In this direction 100 sin 60, root 3 by 2, 100 into root 3 by 2, which is 50 root 3 Newton. Like this, different directions it will have different magnitudes. So vectors will have different magnitudes and different directions, means according to direction the magnitude of vector changes. So third character is, according to the direction the magnitude changes. Like this, it have three characters. So vectors means not only magnitude and direction. So they follows three characters. They will have three characters. First character, vectors follows the laws of vector addition. Second one, vector can be resolved into components. According to the direction of the vector, magnitude changes. According to direction, the magnitude changes. Right. Now let us see scalars. Before going to that, vector means the physical quantity which has both magnitude and direction called as vector. Vector means vectors. Let us take the physical quantities which have both magnitude and direction, both magnitude and direction. These are three characters. Now, what are the examples? Let us take some examples. Displacement is a vector. Displacement. Velocity is a vector. Acceleration is a vector. Force is a vector. Weight is a vector. Tension is a vector. And momentum is a vector. Impulse is a vector. And torque is a vector. Torque and intensity of gravitational field. Gravitational field is a vector. Electric field is a vector. Magnetic field is a vector. Magnetic field. And magnetic momentum is a vector. Magnetic moment. Magnetic flux is a vector. Flux density. Magnetic flux density is a vector. Magnetic induction, nothing but magnetic flux density is a vector. And current density. Current density is a vector. Current density. And amplitude is a vector. These are all vectors. Now, let us see about the scalars. Note down this one. Now, let us see about the scalars. Scalars means the physical quantities which have only magnitude. The physical quantities which have only magnitude without direction. Without direction are called scalars. Without direction means some physical quantities will have unidirectional. Unidirectional. Some physical quantities will have direction, scalars, like electric current is having direction, but they are unidirectional. And let us see some examples. Distance, mass, length, time. First of all, mass, length, time, distance, speed, density, volume, and work, power, energy, heat, temperature, pressure, and surface tension, unidirectional. Surface tension, pressure is unidirectional. Surface tension, viscosity, and velocity of sound, velocity of light, and magnetic pole strength, magnetic flux, electric current, and potential, resistance, capacitance, inductance or scalars. Examples, some examples. So, these are scalars. And the third type of physical quantities are called as tensors. Tensors. Here I am taking a body, disc is taken, it is rotating about an axis, mass into this is rotating like this radius, mr square is called as moment of inertia. The inertia of a rotating body is moment of inertia. This moment of inertia in this direction one value will be there. I am taking a body like this, radius is more in this direction. So, it will have some moment of inertia. Now, this same body is rotating like this, moment of inertia decreases because radius of gyration decreases. Like that, according to the direction, the moment of inertia value changes. Vectors magnitude changes according to the direction. So, it should be a vector, but if it is a vector, the magnitude should be same in all directions. Moment of inertia cannot be resolved into components. Remaining two vectors it should follow. If it is a vector, it does not follow. So, it should be a scalar. So, it is, that means tensors are neither vectors nor scalars. If it is a scalar, the magnitude should be same in all directions. Magnitude is not same in all directions. Like that, moment of inertia is both vector and scalar. Sorry, is neither vector nor scalars. The physical quantities which are neither vectors nor scalars are called tensors. Tensors, this is, here one point is there, tensors never be negative, tensors never be negative, never be negative. So, let us see some examples of tensors, 3 examples: moment of inertia, stress and strain, these are tensors. So, 3 types of physical quantities we have: vectors, scalars, tensors. Here some physical quantities, element, small length, small area will be there, they are called as vectors, they have taken as vectors. That means one bit elements like length dl, small element dl, small length, and surface area, small area dA, and angular displacement, angular displacement, d theta are vectors. When they are large, they have taken as scalars. That means surface area is both vector and scalar. Small area taken as a vector, large area taken as scalar. Elements, small length, small area, small angle taken as vectors. Like that, we have 3 types of physical quantities: vectors, scalars and tensors. Now, note down this one. Right. Now, what is meant by a vector? Here I am taking a force of 10 Newton. Another force is applied on the body, 20 Newton. Total force acting is 30 Newton. this force in magnitude and direction we will represent by a line segment. ఒక చిన్న లైన్ సెగ్మెంట్తో రిప్రజెంట్ చేద్దాం. ఈ లైన్ సెగ్మెంట్ని వెక్టర్ అంటారు. వెక్టర్ ఏ 10 న్యూటన్, వెక్టర్ బి 20 న్యూటన్, వెక్టర్ సి ఏ ప్లస్ బి 30 న్యూటన్. ఈ లైన్ సెగ్మెంట్ని వెక్టర్ అంటారు. సో వెక్టర్స్ మీన్స్ the line segment which represents the vector physical quantity both in magnitude and direction. The line segment which represents the vector's physical quantity, both in magnitude and direction, right? It is. So this is called as vector, line segment. Now you note on this one. Let us see some types of vectors. Types of vectors, let us see. Types of vectors. Here I am taking two vectors, A and B. Both have same direction but different magnitudes. Same direction, different magnitudes. They are called as like vectors. And two vectors have different magnitudes, opposite direction. They are called as unlike vectors. And two vectors have same magnitude, same direction. They are called as equal vectors, equal in magnitude and direction, equal vectors. And two vectors have, this is A is equal to B vector. A is a vector, B is a vector. So A is equal to B. Both have same. Here two vectors have same magnitude but opposite direction. A is equal to minus B. They are opposite vectors, opposite in direction. And when two vectors are acting along the same line, they are collinear vectors. Of course, all are collinear vectors. Even though they are parallel, they are collinear vectors. And two vectors are starting from the same point, concurrent. They are called concurrent vectors. And co-initial vectors. They are called as co-initial. ఒకే పాయింట్ దగ్గర స్టార్ట్ అవుతున్నాయి. యాంగిల్ బిట్వీన్ దెమ్ థీటా. ఎప్పుడైనా కో-ఇనిషియల్ చేసిన తర్వాతే యాంగిల్ తీసుకోవాలి. వీటిని కాంకరెంట్ వెక్టర్స్ అనుకుండా అంటాం. కాంకరెంట్ వెక్టర్స్ అని కూడా అంటాం. సేమ్ పాయింట్ దగ్గర స్టార్ట్ అవుతున్నాయి. కాంకరెంట్ ఫోర్సెస్ అన్న సేమ్ పాయింట్ దగ్గర స్టార్ట్ అయితే దాన్ని కాంకరెంట్ ఫోర్సెస్ అంటాం. And the seventh one, we are taking two vectors in a plane, xy plane లో రెండు వెక్టర్స్ తీసుకున్నాం. A1, B1. They are coplanar vectors. వీటిని అదే రెండు వెక్టర్స్ని డిఫరెంట్ ప్లేన్స్లో తీసుకున్నాం. x యాక్సిస్, y యాక్సిస్, z యాక్సిస్. xy ప్లేన్లో ఒక వెక్టర్, yz ప్లేన్లో ఒక వెక్టర్, zx ప్లేన్లో ఒక వెక్టర్. ఈ మూడు వెక్టర్స్ కూడా మూడు డిఫరెంట్ ప్లేన్స్లో ఉన్నాయి కాబట్టి దే ఆర్ నాన్ కోప్లేనర్ వెక్టర్స్ అంటాం. నాన్ కోప్లేనర్ వెక్టర్స్. అండ్ we are taking a vector. Here you see here I am taking, here a vector is taken, xi vector. This is the magnitude x and this is the vector. This vector I is called as unit vector. It is called as unit vector. Unit vector means the vector which has unit magnitude and directed along the same direction of the original vector, that is called as unit vector. This is unit vector. Similarly, a bar, a vector is taken. For this unit vector is a cap. So, unit vector formula is vector by magnitude is the unit vector formula. Vector by magnitude. A cap is equal to a bar by a bar modulus, that is equal to a bar by a. ఇది యూనిట్ వెక్టర్ అంటమాట, వెక్టర్ బై మ్యాగ్నిట్యూడ్. xi వెక్టర్ ఆ యూనిట్ వెక్టర్ ఎలా వచ్చింది అంటే xi వెక్టర్ని మ్యాగ్నిట్యూడ్తో డివైడ్ చేస్తే యూనిట్ వెక్టర్ వచ్చేస్తుంది. సో దిస్ ఈజ్ అ ఫార్ములా. సో ఫ్రమ్ దిస్ వీ కెన్ రైట్ a బార్ ఈజ్ ఈక్వల్ టు a magnitude into unit vector. What is the unit vector magnitude? 1. ఇది యూనిట్ వెక్టర్. అండ్ నెక్స్ట్ వన్, ఒక డిస్క్ తీసుకుందాం ఇలాగా. ఈ డిస్క్ రేడియస్ 4 మీటర్స్ అనుకుందాం. ఇక్కడ ఒక పాయింట్ తీసుకున్నాం, దీని పొజిషన్ చెప్పాలి. ఈ సెంటర్ నుంచి 4 మీటర్స్ డిస్టెన్స్ ఉంటుందో సరిపోదు, ఎందుకంటే అన్ని పాయింట్స్ 4 మీటర్స్లో ఉంటాయి. కాబట్టి రేడియస్ ఒక వెక్టర్గా తీసుకోవాలి. ఈ రేడియస్ వెక్టర్ ఈ పార్టికల్ యొక్క పొజిషన్ చెప్తుంది, దాన్ని పొజిషన్ వెక్టర్ అంటారు. పొజిషన్ వెక్టర్. పొజిషన్ వెక్టర్స్ ఎప్పుడు ఆరిజిన్ నుంచి స్టార్ట్ అవుతాయి. పొజిషన్ వెక్టర్స్ ఆల్వేస్ స్టార్ట్స్ ఫ్రమ్ ది ఆరిజిన్. ఇట్లాగా పొజిషన్ వెక్టర్స్ ఎలా ఉంటాయంటే r ఈజ్ ఈక్వల్ టు i ప్లస్ j ప్లస్ k, 2i ప్లస్ 3j ప్లస్ 4k, i ప్లస్ 2j ప్లస్ 3k ఇట్లా ఉంటాయి. సో పొజిషన్ వెక్టర్ r ఈజ్ ఈక్వల్ టు xi ప్లస్ yj ప్లస్ zk ఇలా ఉంటాయి. xi ప్లస్ yj ప్లస్ zk ఫామ్లో ఉంటాయి పొజిషన్ వెక్టర్స్. ఓకే, ఇక్కడ ఒక ఎగ్జాంపుల్ చూడండి. ఒక పార్టికల్ ఏ, పొజిషన్ ఏ ఫస్ట్ పొజిషన్, సెకండ్ పొజిషన్ బి, ఏ నుంచి బికి వచ్చింది. ఫస్ట్ పొజిషన్ ఒక పొజిషన్ వెక్టర్తో రిప్రజెంట్ చేద్దాం r1, రెండో పొజిషన్ సెకండ్ పొజిషన్ వెక్టర్ r2తో రిప్రజెంట్ చేస్తాం. సో ఏ నుంచి బికి డిస్ప్లేస్మెంట్ ఎంత అవుతుంది అంటే s ఈజ్ ఈక్వల్ టు r2 పొజిషన్ వెక్టర్ మైనస్ r1 పొజిషన్ వెక్టర్ చేస్తే మనకి s వచ్చేస్తుంది. లేదా r2 ఈజ్ ఈక్వల్ r1 ప్లస్ s, r12 మైనస్ r1 ఈజ్ ఈక్వల్ టు s. ఇది పొజిషన్ వెక్టర్ అంటాం. ఓకే, నోట్ డౌన్ దిస్.